Okay. Okay.
Hello.
Please join the.
Hello, am I audible? Hello, am I audible? Thank you. Thank you, Parvez. Suman. Thank you. So I welcome all the participants in this FDP on the basics of image processing with application. So we will we will start our journey in exploring this field. Before it, uh, we are really very grateful to the EICT Academy, which is Electronics, Information and Communication Technology Academy, uh, which is basically facilitating this platform to share the knowledge from the different colleges at the among the colleges. So just a few words about the EICT Academy. That it was basically set up as a unit in IITs, triple IITs, NITs, uh, in 7 states for faculty mentor development upgradation to improve the employability of the graduates in various streams with the financial assistance from the central government. So here mainly focus upon the different types of specialized training with hands-on basic and advanced level topics for engineering, domain-based training on use of ICT tools and techniques for non-engineering, training and consultancy services for industry, curriculum development for industry, continuing education programs. So there are these 7 type of academies which are basically working on the new emerging areas in electronics, in information communication technology. Anyone who is teaching courses in colleges in the engineering, they are basically considered eligible for this faculty training. So today, see, in this modern world, when quality is the key, so in one word, it is a that connecting platform for all. Now, coming to our part C, the basics of image processing with application. So when we talk about see this word, so what do we mean by this thing? See the image processing. See when we see this word, see as soon as you ask any person, if you ask any person to close the eyes, see what does the person see? They would again actually report the different type of images in their mind, right? And what would and when you will ask anyone to explain about the things, they will basically process those images, right? They will process those images, they will find out the meaning from those images which is inside them. But now the major question is that uh, can we transfer this ability at the automatic level or at automation level? What do you mean by the automation level? For example, can I give this power to a machine? So the answer basically was given by those engineers who had been working on these computer vision, this image processing. They gave the answer, and it basically came out in the form of the fundamentals of these image processing. So how basically machine can be trained, how the artificial vision can be created. That is all about the image processing because that is so basic. That is basically so basic uh, to deal in this world. That's why it is necessary. So we start with it. And another part, see, not only we will read the basics, but also we will go over the application. Applications, the different type of popular applications which are popular in basically the research, etc. That we will go through it. Now, see, now going in also few participants at the query see that what is basically the attendance criteria, what is basically the quiz criteria, etc. Because everyone is not only everyone is eager to learn, but they also want to learn. They also want the certificate. So definitely see it is. So just to make the things very clear, see what we are going to do. Again, see here, see, without attending the course, you are not going to understand it. So we have put some minimum constraint, minimum around 75% attendance, right? So you need to be there so that at least you can understand what is going on at this level. Apart from the attendance, see, there are the quiz will be there. Quiz, your participation is mandatory. So what you have gone through the thing, again, it is based upon the same content what we are delivering here. Whether are you able to understand it or you are not able to understand it. So this is the one. But remember here, quizzes are not that difficult. They are based upon this concept only. Only see what is required from your part, that it is your participation. Definitely see all you people are working at the different organizations, and you have also the other responsibilities. But please try to join it. We'll also provide this material on the Canvas, etc. also. Somehow, if you are not able to join for some day, you can see refer the material there. We can we started. I hope see these are the two things which because we mentioned received many emails, etc. and many queries on the WhatsApp group. So now see, so what is our vision? What is our vision or what is our objective in this course? Our objective in this course is that see how is the basically the image is processed by that machine. Which see for example, what type of machine today see we are talking about basically the automatic car. Just now, see, 2-3 days before, you would have heard a news that one automatic car was there. Some in the US, in Washington, some woman had some problem. The passenger woman had some problem, and then automatic car, with the help of the input, she took her to the nearby hospital, and it was really a big landmark that they can also respond very well to the different type of emergencies, different type of problems in this world. So this automatic car, see, remember automatic driverless car. So it is going on the road. It is automatically following the your traffic signs. It is taking the directions, etc. So that is overall the basically you see the most immersed picture of the image processing. In the all in the basics, it is image processing. So that's we are going to see. But how does it happen? One query is there. How such a complex application take place so easily? So that we are going to cover with the help of the basics. If you are so introduction, applications of image processing, that image acquisition, image sampling and quantization, image representation, basic relationship between pixels, fundamental steps in image processing, image enhancement using spatial filtering. Because it's basically the spatial domain, so we are saying the spatial filtering, image enhancement using spectral filtering. So when we take basically the frequency domain, so that is basically the spectral filtering. So apart from it, we will continue with the image. So if you would have seen the basically the course page, there you would have noticed these things. Different modules are there. So we will try to cover sequentially the things in the form of the module. Thereafter, we will follow the image compression, morphological operation, image segmentation, feature extraction, and then the reference, and then to our research team. So now see, whenever you have the question, you can always ask on your chat box and interrupt it, so that see our main purpose is that see after going through the basics, you can able to follow the any type of code, right? Because it will give you the confidence that you can do the research or if you want to pursue any course, you are able to understand it. That is the holistic purpose of it. Whenever you have the questions, uh, please feel free to interrupt me via the chat box. Now, see, coming to the part C, image processing. It is two parts, see, image is there and processing, right? So, image processing is basically a form of information processing, where the input is an image. What type of image? What you are seeing on this slide, basically, that is the photographs or frames of video. What is the difference between basically video and the photograph? Video is basically a sequence of many photographs. So that is basically the input. It is photograph or frames of video. Then what is the output? Output after processing it is again the output of image processing can either be an image or set of characteristic or parameters related to the image. What do you mean by the characteristic or parameters? For example, some information is interpreted. For example, I am processing some image. For example, again we take up the example of the driverless car when some object is coming, right? Remember something is coming, then it is detecting that some person is there, some image is there, and how will it respond? It will basically it will give the command that it needs to stop it, etc. It can also be the in form of the image also. Output is not, output is flexible, but input is definitely photograph or the video. So most image processing techniques involve treating the image as a two-dimensional signal and applying standard signal processing techniques to it. Whenever we want to understand anything, it's basically in form of the signal. What do you mean by the signal? Where things are changing with respect to the time. So here it's basically a two-dimensional signal. What two-dimensional? It is basically the what you are see that it is basically the x dimension, y dimension. Somebody may say that the video is three-dimensional, but again, see, when we will take it for the processing level, we will take it at the two dimension, right? Initial input can be of any size, but finally, when we are processing, whatever basics are there, that is on the two dimension. So where these things are applied? These things are applied in basically medical application, starting from the cancer detection. It is remote and assisted surgery. Uh, security application. So where face and fingerprints recognition are there. You would have thinking see how the cancer detection, even see we are also able to see the cancer film, etc. For example, the PET scan, CT scan, how the here image processing will help. But remember, see, we can see at some level, we can note the key information. But with the help of the image processing, the processing can happen at very, very deep level, at very micro level. Because see, many times we see that the main is, for example, for the cancer detection, main tumor may not be there, but for example, if at the micro level, many, many small type of dots are there, this pattern also indicates something. So to bring out everything, the clarity, the image processing becomes very, very useful. Initially, it started at a level that it would basically, whatever human is doing, it will assist at that level. But later on, with the help of the flexibility or the image operations, it has gone above the human level in many, many cases. For example, the medical one, remote and assisted surgery. Today, see, we are able to see that in operation theater, the operations are able, doctor is able to do within 1 hour, 2 hour. Earlier, basically, it took time of 2 day, 3 day. Why? Because with the help of the again the see the camera, they are able to see where they have to make the cut, etc., where they have to do the things. And with the help of the robot, etc., things have become very, very precise. What is really important here, that accuracy and precision is become very, very helpful. Now coming to the security applications. What do you mean in security applications? If, for example, some house is there, right? I don't want to put up the key in my pocket or don't want to carry it. What is the way? Way is there so that you go there, as soon as you show the face, the gate will automatically open. It's exactly the same way. For example, on the mobiles also we can see that the as soon as you show your face, your screen is unlocked. Fingerprints recognition, not only for the security purpose, but also for the attendance part also these things are checked here. Think, commercial applications, it is a video and photography enhancement. People do the thing. It is the industrial application, the assembly line manipulation, visual inspection. See, in industry, when you need to do the many things that do not only many things and also it very quickly. For example, you have to do the packaging of some product. Then also we use the image. See, for example, correct thing is coming, then the process can go on. If the correct thing is not coming by seeing the picture, then definitely it will follow the other command. It will again ask to provide the another material for the packaging. Military application. Today, what we see that the missile guidance, etc. As we discussed that image is the key thing where we connect with the world. So the military application, when you have to target it, see, today we are able to we hear the different type of news that the dead terrorist or etc. had been killed in their house. How is it possible against with that type of vision? That from the many kilometers you are able to see that person and with very sharp velocity target a shootout. Space application. In space applications also the remote sensing. For example, different type of satellites are going on. So different information is provided from those applications in the form of different images. Space robotics. For example, we are also planning to send a manless mission where robots will be there. So they will basically take the image and we will able to know the information in the space. Either it is the moon or the Mars of the different planet. Now coming to see this, when we are taking this image is not only related to only electronics or computers only. If we really go into the detail, even in the course, when participants from the different streams have joined it. So why is it so? Because it's basically a multidisciplinary field. What type of things are there? Here you see that in physics, it is used in physics also. How is it used in the form of physics? It is basically the optic. It is the imaging sensor. In the mathematics, it is basically used as a probability, statistic. It is scientific computing. In the engineering, in the basically electrical engineering, what you see it is basically signal processing, automatic robotic control. Neurobiology, it is biological vision, it is the psychology. There also image processing is used. Computer science, it is the data processing, it as well as the storage and the artificial intelligence. Image processing provides the key thing. Now, after see realizing that image is image processing is such a useful task, starting from the earth, medical, security, as well as a spatial application. But we will try to touch the fundamental question. What is image? Remember, when we are trying to address these questions, we are trying to address these questions so that we can explain that image to a machine. right? Because here we are talking about the image processing by the automatic machine. What is basically the image? Image is a two-dimensional function. As we just discussed it, that image is a two-dimensional signal. So what is basically signal? As we understood that signal is basically with something which varies with the time, which is not constant. So if you see the things at the mathematical level, it is a two-dimensional function where x and y are spatial coordinates, right? As we discussed, it is a two-dimensional. And what is f? F is basically the whatever the values are there on those x, y level. That is basically the function. So this is basically the what we call it. These are the spatial coordinates x and y, and this f is basically represents the image values of the different parts of the image. What is this f? This is basically called the intensity. This is the intensity or gray level of the image at that point. So what do you mean by this intensity? That we will see, that we will analyze, that how bright is there, whether it is white look, whether it is dark look, gray look. So this is basically the scale. So that's why we are, so what do you mean by the gray level? Gray level means the between the black and the white, there are the different type of shade. So that we are able to observe in the image. Somebody may raise a question, see what will happen to the color? See, when you talk about the color, then it becomes basically it doesn't remain the two-dimensional. It becomes the three-dimensional, even the multi-dimensional. For example, the RGB level, red, blue, green. So this information is not actually required for the processing by a machine. Why? Because even see we can do it, but we want to make the things simple. We want to make the things very quicker. That's why we are dealing with this basically the gray level. What you are seeing here, that this gray level is very important. So gray level is basically the different shades between the black and the white. Two types of images are there. One is basically the analog image, another is the digital image. So what do you mean by the analog? Analog, if you recall, analog is basically continuous. Two meanings are there. What is basically in the common terminology? It is a continuous one and it is a digital one. What do you mean by the continuous and digital? Digital means there are the different boundaries are there. Many boundaries are there, but in continuously, no such any clear-cut boundary is there. It is a continuous phenomenon. What you are gray level couldn't be 3D. No, gray level couldn't be 3D because in the gray level, see what you are seeing this image. This is, for example, here you are seeing the image. See, remember, because see, here we are only observing the intensity. Intensity, for example, you can take this example. This is 56, 57. These are the different, see, for example, you are seeing here. So these are the different points and here it is 56, 56. So this is the shaded value. The shaded value, we are saying that this is the intensity. Analog images are the type of images that we as humans look at. Because as a human see, what we are seeing all the images, we are seeing the continuous images, right? Which include photograph, painting. TV images, and all our medical images recorded on film or displayed on various devices such as computer monitor. We never ever see that that part of image is different or that type of image is different. We are completely seeing the one picture. But this is the basic difference between us and the automatic machine. What we see in an analog image is various levels of brightness and color. For us, colors is also visible. It is generally continuous and not broken into many small individual pieces. So, one example is seeing there. For example, when you are taking basically the chest X-ray, it is looked in that form. When the mentioned mathematical representation has a continuous range of value, right, represent position and intensity, the image is analog. So what we are seeing here that is a here you are seeing here that the image is analog one, image produced on the screen of this CRT monitor. But in the digital image, the digital image basically recorded as many numbers. The image is divided into a matrix or array of small pictures, elements, or pixels. What do you mean by this pixel? See, this pixel is basically the smallest quantity or the most basic quantity of an image. What you are seeing here. What we are seeing here, there's 0, 0, 1, 0, 2, 0 to capital N minus 1. See, this is basically an example of the M by N dimensional image. This 0, 0 is basically the position. This 0, 1. What we are saying that this is the 0th row. And this is the M minus 1. How many total rows are there? Total rows are there, capital M. And here, when we are seeing here, when we are starting from this one, this is basically the capital N. So this coordinate is changing 0, 0, 1, etc. This thing. So what are these locations? These locations are basically the pixel. And what do we observe about the pixel? We observe basically the intensity. And what is the pixel intensity? That value is given by basically the F0. What we are saying in numerical value represents each pixel. What does that represent? That basically represents the pixel intensity. Pixel is basically the part, sub part of the image. Advantage of digital image is that they can be processed in many ways by computer system. Now you see, it is unlike the human see when we take the total image and we want to process it together only. Computer can take a small part, maybe the central part, it may be the peripheral part. Those parts can be taken and the image processing can be carried out. That is basically the flexibility at the automatic level. Some people would be thinking that are they totally different, the analog and the digital image? No, see, even analog image can be converted into the digital image. Actually, why we consider the digital image? Because the digital image is far easy to process and far quick to process in comparison to the analog image. So what do you do in the analog image? You basically do the sampling, and thereafter, what do you do in the sampling? Here you take basically some samples. What do you mean by the samples? Samples means basically you are taking some part of the signal. Some part of the signal, we call it basically the sample. Hereafter, when we are taking the samples, you need to also measure it. Need to give the certain level. And that level will be the only, it will be the only integer value. For example, when we are taking the quantization parts, the intensity of the image may be 100, 100, 1, 102. It will not be 100.5, not be 20.5, etc. When we are saying quantization, we are saying it is a complete integer. So what we are doing, so how basically the difference between digital image and analog image, that here you are taking basically the part of the image, some part of the image, not the complete image, and then you are assigning the different levels which may be represented by complete integer. Hope this part would be clear. If any question, if you have. So the question is there that if we have an analog image, we need to convert it to digital before giving it as an absolute. Siddhant, yes, you have pointed out very correctly that whatever see these analog images are there, they are converted to digital image. So this sampling and quantization are the key part, which are to be carried out in to any image processing machine. So different type of quantizer in your electronic circuit, etc. These are the key circuit. These are the part of that circuit. And other thing. So now we see the image. How does basically they differ, analog and the digital image. When you are seeing basically this analog image, this is image, you would have recognized that person. Barack Obama, he is the former president of the USA. What we are seeing here that in the continuous image, it is far easy to analyze, but remember we are talking about the machine level. Where does the machine find convenience? In that case, it is basically the digital one. So what is the difference here? Difference here is that if you are seeing that it is basically the different parts are there. Here, if somebody asks me, it's a continuous boundary between black and red, but here you can easily able to find out the boundary. Here we are seeing the different values. What are these values? These values are basically the pixel. That is the one. Now, see, coming to the part, see, when we are, it is also important that how do we acquire the image? Images are basically typically generated by illuminating a scene and absorbing the energy reflected by the objects in that scene. What is the key thing? Key thing is basically that light, illuminate. And when you illuminate that thing, the energy is absorbed, that reflected energy is basically absorbed by the objects in that scene that you are seeing here. What we are seeing here, that how that illumination source is there. After illumination source, for example, a scene is there, and then imaging system and the projection of that scene onto the image plane, and then digital. First, we have taken this basically the analog image, and then thereafter we have taken the digital image. Typical notions of illumination and scene can be way of X-ray of a skeleton, ultrasound of an unborn baby, electromicroscopic images of molecules. So, in image acquisition in other ways also, for example, here we are seeing the different persons in a car. So, at the rear seat, there you can see these different persons. How they are detected basically? They are detected basically using the radar, wave radar. Some people would be thinking that how the image is involved. See, the image is involved here, that here point cloud is generated. it is 3D point cloud is generated, which is converted into a 2D. Why this medium is there? See, this medium becomes important when your illumination is not available. So many times in night, etc., you want to detect the thing. There it becomes difficult using the illumination. So then this approach, wave radar based approach, becomes used. Then what we are seeing, image sampling and quantization. So now we go into the detail of that part, that how do we sample the image and what is happens at the quantization level. That is overall, it is called basically in the digitalization of an analog signal. So digitalization of an analog signal involves two operations, sampling and quantization. Both operations correspond to the discretization of a quantity, but in different domains. What do you mean by discretization? Discretization means, for example, some value is there. It is 10.5 or it is 8.5. So we will assign either it is the 9 or the 8 to that value. So this is basically the discrete number. To convert an analog image into a digital image, we have two intermediate steps. So what are those steps? That we basically digitalize the coordinated values. It's called sampling. And digitizing the amplitude values is called quantization. It is image sampling and quantization. Here also it has been shown that continuous image is shown here, and then a scan line showing the intensity variations along line AB in the continuous image. Thereafter, see what we are doing basically the sampling in the C parts. What do you mean sampling? Sampling means you are taking the different interval. You are taking the some value, some particular value. For example, this 1, 2, 3, 4, 5, 6, 7, 8. You have taken the in between part of the image. Then what? So which are those parts? Here they are clearly seen in this D part. So this is the one. These different values, instead of taking the complete signal between A to B, we are able to encode the signal into a some value that we are seeing. Continue from this part, continuous image is basically projected onto a sensor array that you are seeing here. Again, it is the digitalized part. Image representation. Image representation, image acquisition. We recall that the digital image is composed of M rows and N columns. What we have seen in the earlier diagram of each pixel is storing a value. Upload this slide, you are going for. Okay, sorry. Definitely, see, we will upload it. Material will be provided to you. In some case, if you are not able to attend the full session, or you are definitely, all the things are taken into account. So material will be provided to you. You will able to access it using that canvas. Right? All you would have able to do the login there. So no issue. You don't need to worry about it. So pixel values are, will the recordings be provided? Yes. Recordings will be provided. All these sessions. Yes, they will be available to you. So pixel values are basically the most often gray level in the range 0 to 255. See what we record, see that basically the black, what does the black indicate? Black indicates basically the 0 value. White indicates basically the 255 value. And the in between values, in between the different shades are there, that are basically the different gray level. That is gray level intensity. And see, you really see the beauty of the image processing, that it is with the help of this intensity only, we are able to differentiate and we are able to identify the object instead of using the colors, etc. Because colors actually, definitely see color actually provide a very easy way. But when we are going for a machine, what is really important? It is the amount of processing. Because when you take basically this red level, this blue level, this yellow level, the one extra dimension is added. Your signal dimension becomes much more large, and when it becomes much more large, it is not easy to quickly process that signal that you are seeing here. It is image again. See, in the spatial coordinates form, you are able to see here that what are these different dots. These different dots are basically the pixel. How they are differentiated? Each pixel is differentiated with the help of their neighborhood and uniquely by their intensity. What is the intensity? What do you mean the intensity, and what is the range? That the intensity will lie between the 0 to 255. So again, see what you are seeing here. This is another diagram. Can you identify, see this, which this diagram is there? Again, see to this is the digital image, what you are, it is basically the face of the person. Right? We are able to recognize the face of the person with the help of the pixel. What we are saying here, we are seeing the different shade. Here it is a complete white, and here it is a complete black. So between this white and black, the information is captured in form of the gray scale, the gray level. So first the image has been, the normal image has been converted into digital form, and then thereafter converted to digital form, we are basically writing the different pixel value, right? And then the image, initial image is also not required. Only these pixel values, only these pixel intensity values are sufficient to do the any type of operations. In the last image, see, even this black white, this is not required because now it has been converted into some mathematical form. So here what you are seeing, it is this 157, 156 different values as we shown till the 190, and here it is the 218. So these are the different values of a pixel. Again, see, you can notice here the dot basically, which is more white. That is, more white means it is more closer to the 255. What you are seeing exactly as the black here, that value you can easily see here that it is basically the 0. Are you able to see the our assigning of the values between the gray level and that number? All the numbers lie between 0 to 255. 0 means the most black, and 255 means the almost white. Are you able to differentiate? I want everyone, those who are seeing it, they can use their image processing, their natural image processing, and can respond here. So one question is also there from the many questions here. What will be the values for n color image? What is this n? See, for if I understand it as the color dimensional, so for example, it is a, if red color is there, if it is blue color is there, yellow color is there, then then there will be three such two-dimensional values at that level. One at red, one at the blue, one at the yellow. So it will be three times information processing will be the three times. Isha has also asked some question. Is it so that if we have more number of rows and columns having these pixel values, more will be the resolution of the image? So we can alter the number of rows and columns as per our requirement. Very good question. So see, Isha, see, for example, these days, if, for example, when we are using this mobile actually, so what we are saying, see, in mobile, what is the key feature? Somebody say it is the 1 megapixel. Somebody say, no, this iPhone is 10 megapixel, 100 megapixel. So what do you mean by this C pixel? It means that is basically these number of pixels. How in one image, how many pixels are there? So definitely when you are saying, when you are taking the 1000 pixels in an image in comparison to the 100 pixel, then definitely it will be much, the resolution will be much. You are able to note down the very, very key detail of that image. It is absolutely true. Any other question? I'm really happy to see your participation, because this is actually the prime purpose of this course, that you are aware about the basics and then aware about the fundamental which you can apply to anything. Apart from these questions, if you have anything. My question is that are you able to find, are you able to see this relationship between this white and the black? What is the middle value between the 0 to 255? If we really see, it is the 127, 127, 128. What is that value? Are we able to see here? If we go here, yes, it is this value. This is the in between. This is neither actually, it is almost, it is equal value. 121, 123. What you are seeing, this is the equal value. Again, see here we are seeing it is a more white. Those who are able to see the relationship, they can respond as yes. And those who are not able to see the relationship, they can also answer no, so that at least we can again revisit it. No issue. I guess. So the very, very clear-cut relationship. Once we are aware about the see, because remember, whatever algorithms we are designing, etc., they are very well designed only in the way we interpret it. We only write the algorithm. Pravesh is saying that different images can have different pixel metric. While doing the process, do we need to normalize in some specific format? See, yes, definitely. You are coming to the application part. See, when we are doing the image processing, actual image processing application, we need to normalize it later. That actually become the more advanced part. Yes, we need to do it. See, for example, I am taking the image from the different sources, and then I have to merge those images, etc. Then also I need to normalize. Or, for example, I am taking the image from the two different sources. One is at the one place, another is at the another place. Then also you need to normalize, because you need to do the common operation on both these images, that you can rule out the external factor or the uncommon. Does it answer the question? We can read further. So, what is the basic relationship between pixel? Pixel is basically, what is this? Pixel is basically this region, or this basically location. So, apart from the pixel intensity, many other things are important. What is basically thing that the neighbor of a pixel? That pixel is important, but it in its neighborhood also. What do we say? We say the collective processing. Always, many times the information is not provided by individual pixel processing. In that case, we basically take the neighborhood of a pixel. Another thing that the distance measured. What do you mean by distance measure? Distance measure is basically, for example, distance measure means basically, for example, x1 minus x2 whole square plus y1 minus y2 whole square. So the distance measure, it is based upon that spatial location of the pixel. So for example, as we have already seen it in our image, see this 0 to n minus 1. For example, if I want to find out the distance, for example, between to this and this. So what is the value here? Here value is capital N minus 1, here capital M minus 1. So the value here is N minus N square plus capital M square. That will be the distance between this diagonal element. What is saying that pixel is basically also helps to calculate the distance measure. Boundary. See, boundaries becomes a very, very critical thing when we basically recognize the image, when we differentiate the image. So this pixel relationship helps to demarcate the boundary. That here the, see, once by locating these different boundaries, even by mentioning these different boundaries, we are able to understand the overall object. Related what reasons is there. See, boundary is basically almost one line. It may be a diagonal, it may be a vertical, horizontal. It may not be a straight one also, many cases. What about the reasons? Reasons is basically continuous collection of those pixels. When that is noticed, then it is basically the pixel reason. Connectivity. Connectivity also see how, for example, one pixel, is it connected to, for how many pixels it is connected? It is near one, near adjacency, etc. All these, they are not totally the different concept, adjacency and connectivity. Connectivity again, see, not only based upon that the location part, it may also based upon that intensity part also. That in the form of the intensity, you are able to, in term of intensity, you are able to demarcate the line based upon the intensity. There also connectivity is. These are actually different terms, but they are not totally different from each other. Adjacency is basically the nearby region, right? Now we make the things clear by this diagram. So this is the basic relationship between pixels. As we have discussed in the last slide, for example, the four diagonal neighbors are there for xy pixel. What is this? X and Y. X and Y are basically the spatial location, right? This is X and Y, and here, as you are going the up column, it is Y plus 1. Here you are going on the right hand side, it is X plus 1. When you are going on the left hand side, it is X minus 1. On the down one, it is X, Y minus 1. So this set of pixels, which set of pixel? This 1, 2, 3, 4, which are all this one, they are called the four neighbors of, is noted by the capital N subscript 4. So what they are saying, this is basically P is basically that initial pixel. That only four neighbors only possible, or is there any other arrangement? Also, can we see any other arrangement in the same figure? Can you answer? Is there any other arrangement apart from this four neighbor? Yeah, Rishiraj is saying 8 neighbor. Which are the eight? This one? Yes, diagonals also. Yes, it is there. This is 1, this is 5th, this is 6th, this is 7, and this is 8. So overall, it's a 8 neighborhood problem. But again, see, depending upon our problem, depending upon our objective, we basically take the different type of pixel. We consider the different type of neighborhood region, the 4 or the 8. So when we consider these four diagonal neighbors of pixel, it is mentioned here. So the green, it is x minus 1, y plus 1. What is different in the diagonal and the neighborhood element or diagonal and the adjacency one, that here two values are changing. Here see only x and y, only y is changing. Here x plus 1 y and xy, here x is changing. Here x, y, here only x is changing. But when we talk about the diagonal level, then two values are changing. For example, when x to y, it is x plus 1, it is y plus 1. It is x minus 1, it is y plus 1. So here also it is x minus 1, it is y minus 1. Here again the two values are changing. Here x plus 1, it is y minus 1. That is the key. So any question? So what we have represented it basically that these points together with the four neighbors are called the eight neighbors. Remember, these four neighbors are also the part of this complete neighborhood problem. So at this point, see, we take up a small break, 5 minutes maximum. So see, in between session, long session will be there. We don't want that you are sitting here, all are work, all are working. Take to 5 minutes break and we will be there. Whatever question you have, you can all remember maximum explore these sessions with by raising the question, by understanding the thing. These 10 days periods may not be sufficient to complete the course, but it may be sufficient to bring you the confidence that you can read the image processing, you can deal with any type of research problem on your own. Where we take up a break and we will be back, right? So welcome back all. So I think, so continuing with the part of the relationship, that it is not only the value of the one pixel is important, but it is the neighborhood that is also becomes very important. So that we have just seen in the last slide. So what we are seeing is that there are the different type of neighborhoods. One is basically the adjacency neighborhood where the 4 neighbors are there, and another is basically the 8 neighbor. What do you mean? Is it audible? Okay, Parul is saying yes, it's audible. Everyone, is it visible? Okay, thank you, Parul Jyoti. Thank you. So see, what we are saying here, so this is basically the representation. Yeah, thank you. So what we are seeing that, so two type of see neighborhoods are there. So there is basically 4 point neighbor. Even see more than it is 6 point neighbor are also. But right now at the basic level, we are focusing upon these neighbors. Now we coming to the parts. What is this adjacent, right? Let V be the capital V be the set of intensity values used to define adjacency. In a binary image, V equal to 1 if we are referring to the adjacency of pixels with value 1. So in a grayscale image, V typically contains more elements. In the adjacency of pixels with the range of possible intensity values from 0 to 255, set V could be any subset of these 256 values. So 3 types of adjacency are there, where core adjacency, just we have seen in the last diagram. If you have 2 pixels P and Q with values from V are core adjacent if Q is in the set of N4P. What does this represent? That this is basically N4, capital N basically represent the neighborhood. What is this small 4? It is 4 point neighborhood of pixel P. They basically, another is basically 8 adjacency, 2 pixels P and Q with values from V are adjacent, 8 adjacent if Q is in this set, as we already seen in the last diagram. Remember there, it is not always necessary that it may be the M adjacency also. What do you mean M adjacency? M adjacency is basically the general one that are M adjacent if Q is in N4P or if Q is in N capital DP. What do you mean by capital D? Capital D is basically the number of the neighbors, right? And the set. Again, you can take this number as a 5, 6, 7. And the set N4P oblique, this is common part N4Q as no pixels whose values are from. So mixed adjacency is a modification of 8 adjacency. It is introduced to eliminate the ambiguities that often arise when 8 adjacency is used. You see, okay, adjacency. Again, see, yes, we go to the part. See, let V be the set of intensity value, right? Set of intensity values used to define adjacency. M adjacency, yes, we will come to this part. In a, see what we are saying, see adjacency, again, see it is basically in the neighborhood. It is a type of the neighborhood, what we are seeing here, that in core adjacency, when basically this 4 part is there, it is 8 part is there, but it is not only limited to this 4 and 8. It can be in between also. So that value we are saying basically are the M adjacent. That is basically pair actually. What we are saying here, it is pair. That it is a pair of the 8. 8 plus 1, that is 9. Earlier, it is 4 plus 1, that is equal to 5. So that we can see here. So what we are saying, mixed adjacency is a modification of 8 adjacency, right? So it can be the any value in between. It is introduced to eliminate the ambiguities that see, for example, you do not require all the relationship. Don't need all the neighbors. In that case, the ambiguity comes, and then you same information is repeated. In that case, M adjacency becomes more used. We take up the more example here so that it will make clear. For example, it is 4 adjacency path. What do you know? 4 adjacency path. In 4 adjacency path, what we are seeing here that, for example, this one is here and this one is here, right? In the 8 adjacency, what is here? That apart from this and this one diagonal is also is coming, right? But when we are taking this one, so here what we are seeing, for example, I want to take this one as this neighbor is there, this neighbor is there. 2 links are there. But for example, I am taking when these 4 elements, what is happening here? See, this relation is there, this relation there, but this extra relation is coming here. And this relation is also coming here. So in the M adjacency path, this can be avoided, this ambiguity is avoided, and what we are seeing here that this is in the M adjacency. Now coming to the part connectivity, the neighbors are there. Again, see the neighbors are there. Sometimes it is based upon the location, sometimes it is based upon the intensity. So when we are saying let S represent a subset of pixels, the ambiguity means basically what we are saying that there are more than the relationship, more than the required relationship. For example, what you are seeing here, see that here, for example, I don't want to connect, don't want to bring out into this diagonal relationship. Then this is the extra relationship. Ambiguity means that where it is the more than the required one. Not ambiguity in the sense, I think. Now coming to the part in the connectivity, let S represent a subset of pixels of an image, right? S is basically subset of pixels of an image. Now see, from the pixel, we have moved to a group. 2 pixels P and Q are said to be connected in S if there exists a path between them consisting entirely of pixels in it. Again, we will see it by the diagram. For any pixel, see again we will see what is one thing clear, that S is basically a subset of pixels, right? S is a subset of pixels of an image. Now we are bringing the relationship from individual pixel to a group level. For 2 pixels, P and Q are said to be connected in S if there exists a path between them consisting entirely of pixels in it. So what we are saying in the last diagram, that if there is a path between 2 pixels, which are the set in the S, then what we say that they are connected. For any pixel, P in S, the set of pixels that are connected to it in S is called a connected component. Those which are connected, we call it that they are the connected component. If it only has a one connected component, then set S is called a connected set. Remember, if there is only a one and only one connected component, then your set as S is basically a connected set. Now we move to the regions. Let R be a subset of pixels in an image. Call R a region of the image if R is a connected set. So see, when we differentiate the image, we basically take up the different regions, right? So what is R? Basically a subset of pixels, and we are taking R as a reason when it is a connected, when it is only a everyone has a one connected component. Two regions R subscript I and the J are there. They are said to be adjacent if their union forms a connected set. For example, when their collection, both when we are taking Ri and Rj together, they are basically said to be adjacent if they also form a connected set. Regions that are not adjacent are said to be disjoint. For example, when we are analyzing an image, we are more interested in basically taking the continuous into the connected region. So we need to check out that whether some both are these regions connected or the disjoint. Suppose that an image contains k disjoint regions, then definitely what does it imply? It implies that none of touches the image board. Now coming to the part RU that denote the union of all the k regions. And let R denote its component, capital subscript C denotes component. It is complement of a set S is a set of points that are not in it. I need to show you the diagram. I will better include the diagram and then I will show you this part, right? Better connected. We revisited this section by showing you the more diagram. Now coming to the part, the distance part. As we, for example, many times we want to use the not only the pixel value, but also we want to use the distance measure. Then in that case, how do we measure the distance? Basically, we measure the, for example, for pixels, P, Q, and Z with coordinate. For example, P as coordinate X, Y, Q as the ST, and Z as the VW. Then D is a distance function or metric. If D of P of Q is greater than 0, if it is. So what has been shown here that this distance between the, what we are defining, basically we are defining the criteria. The Euclidean distance between P and Q is defined as this one, where basically it is between the P and Q, the distance between the two pixels P and Q. What is the distance? Again, see, as we defined that this first coordinate denotes the X coordinate, second one as a Y coordinate. So the actual distance will be given by the norm of a square between the X coordinates and the Y coordinates. So for this distance measure, the pixels, so what we say, so in this way we can differentiate the neighborhood of the pixels with the help of the distance. Is it understood? So now coming to the part C, sequence of the image processing. So we now see a complete picture. So what is basically going on here? That we take up the how the actually complete image processing take place, starting from the basic operation. When we are taking basically 3D scene, 3D scene is there, 3D scenario is there, which is actually normal scenario for us. Thereafter, image formation is there. Remember, now when we want to analyze the image, we convert that into a basically 2D image. And the 2D image, then with the help of the digitization and that what do you mean digitization? Again, the two things are there. That is basically the sampling and the quantization. And thereafter, you do the basically the gray level image. In the gray level image, as soon as you have taken the gray level image, so what do you do? Then either it can be done the compression, because sometimes it is required that we want to send that image, want to transmit that image. It is we compress it. Sometimes we need to correct it, and then compression, or then thereafter we can store it. Mining means again then we can explore the different information, and then you enhance the image at the gray level, and thereafter it is at the enhancement. How do you see basically enhancement? There you use a different type of process like the grayscale, histogram modification. It is sharpening, smoothing. Where does the sharpening, smoothing happen? It is again at the boundary level. And then you restore the image, then you reconstruct the image. How do we do it? Restore, reconstruct means basically after the enhancing it. We have enhanced it and then we want to bring back that image. Then we use basically the least square filtering. We use basically the deconvolution. There's the recursive filtering is the maximum entropy. And then thereafter it is this registration is there. So in that, what do we do in registration? Again, we use basically relation like intensity, it is correlation. Here FF basically fast Fourier transform, where we do the feature matching, wavelet based things are there. So this is basically an overview, what you are seeing here, that we will see. And then finally, from the registration, we extract out the features and then segmentation. And thereafter, we interpret the image. So this is overall this overall scenario of the image processing which takes place. If you have any questions, see, just this is the overview. We will explore it slowly, gradually, all these things. And if you have any idea how many are aware about this diagram, how many are not aware, so that it helps you to understand that at what pace I need to. Can you just comment? What you are able to understand in the diagram, how many? If you are not able to understand anything, please write no. If you are able to understand anything, this is a complete picture. After doing this, we are able to understand every word of it. So what do you understand in the diagram sequence of image processing? So this is basically the raw diagram, what you are seeing. Okay, did not get the registration part. Apart from it, any other question? If you want to everyone that how many things you are Definitely. We all will explain to you, but just only I'm asking that how many you are aware so that pace means we can move at the sufficient pace. If it is clear to you, then we can move bit quickly. If it is not clear, then we can put the more emphasis by putting the more diagram, etc. That's only my objective. Okay, no problem about this term, digitization. We will explore every term. Don't need to worry. Only I need to know the participant, how many are. So definitely. So I think we can go at our pace so that you will understand every concept. No issue. Any other one? Difference between segmentation, definitely. We will go over it. Much more difference. Actually, all these part of the, we will go over it. Only what I'm asking that what you are aware about these terms, how many are aware and how many are, if you are aware, please mention it. So, okay, Parvesh, aware positive. Oh. So, okay, you can fine go through these things. It will be a fill the gaps in between. Hope, Parvesh. Okay, no, so we'll go the gradually. I will cover the things in a way so that you will able to gain the confidence. No problem. So this right now, see for the beginners, what those are seeing it the first time, only understand one thing that when we understand the image processing contains these many processes. What type of these different processes are there? So we have reached basically till this part, this gray level image part. We'll explore the other. As mentioned in our course schedule, the different modules are there. We will cover we will have the separate modules upon the feature extraction, image compression, morphological analysis. We have the separate sections. Don't need to worry at all. We'll able to easily understand, master these concepts after going through this course. Now see what are these fundamental steps? Can we club them together? Yes, we can club them together into these parts. What are these parts? Basically, the color image processing, wavelets and multi-resolution processing. What is this wavelet? See, those people who are familiar with the mathematics, they would be aware. See, wavelets means basically that at one point of time, you are not, you are able to know the frequency also. That this frequency component present at that time. Multi-resolution, because see what happens when you talk about the frequency and the spatial domain. That frequency domain only tells you that how many frequencies are present, but which frequency is present at what place. Can we figure out the frequency? Can we localize the frequency? So that information provided by the wavelet. We will not go into the, this is one of the basically feature extraction technique. When we talk about the compression, remember, image processing is a very broad word. For example, the earlier example we have taken that we want, for example, I want to identify the image, whether this image is of the this home residential or not. For example, if I want to give the access to some person by seeing the face, then only this information is required. That if it is in the database, then the gate should open. If it is not there, then the gate shouldn't be opened. So this operation here, remember the input is image, but output is different. But in the compression part, the processing is at a different level. So for example, I want to transmit the image. For example, what is right now going on? Right now, when I'm communicating to you people, what is happening that my image is captured, it is transmitted. It is transmitted over a network. And remember, it is compression is also taking place. So here, so that's why we are saying that it has a different dimension. Image processing, simple word, has a different dimension. Morphological processing. Morphological, that we will see that how does it basically help in the image processing. Segmentation, yes, see segmentation, for example, when we talk about this, we say the basically analyzing the image, analyzing the different part of the images, then we use the segmentation. Even see, for example, I am interested in detecting the tumor, whether the image contains a tumor or not, and if it has a tumor, then in that part of the image, I want to further analyze it. What is the way? So first, I need to segment out that part which contains the tumor. That is basically the segmentation. Then the representation and the description. What do you mean with the representation? Again, see, the description means, for example, somebody seeing the image and you are able to find out that what does this image is about. For example, today, many times we are using, we see that Google camera. I'm using the Google camera, and then after using the camera, after capturing the photograph, I am able to know that what does it, for example, I want to know the tree. I want to know the bird. So after capturing that image of that bird or tree, I am able to, using that my Google camera, I am able to locate that which tree is this one. Object recognition. Again, the object recognition is also related to it. In object, here some particular categories are there. Here some fixed labels are there. Whether this is, for example, this object is solid, liquid, or this object is related with household. Where our categories are well defined. Description is a more broader task. Image acquisition. Again, many times you acquire the image and then you do the process. Image filtering and enhancement. So these are basically the fundamental steps are there where these things are involved. So even if you go into the sequentially, so what is the normal one? Normal sequence here, order is also there. What order is there? That normally it is you acquire the image, thereafter you do the filtering and then you enhancement. For example, just somebody asked that is there any normalization involved? So that normalization is involved in this filtering part. Why do we do the filtering part? So that we can remove out the noise, surrounding noise, and then we can enhance the image in a way so that whatever task we are doing, for example, if we are using to recognize the thing, we can better enhance that aspect. So remember, image processing doesn't mean that we don't alter the image. We alter the image systematically so that our tasks are better carried out. Then image restoration, but definitely we should not miss the detail of the original image. So we restore it also. Then color image, then this is feature extraction, then This is compression, it is segmentation, and then finally it is object recognition. It is not necessarily, it is in this sequence, but generally it is starting with the image acquisition and finally ends with object recognition in majority of the applications. Now see, we come to the part of the image enhancement, right? Image enhancement, image acquire, as we have already seen it in our last slides, what we are doing in the image acquisition. In image acquisition, basically it requires the illumination, and after illumination, the light is basically absorbed by the object, and we are able to capture that image. So that is basically the more physics process. But now we're going to the part as the image processing part, we are interested in this part, enhancement. Enhancement is a process that improves the quality of the image for a specific application. Remember, enhancement can be defined only when you define a context. So that's why we are saying that it is basically for a specific application, you can't generalize enhancement for all. For example, in case of the medical, some doctor is want to observe the image for some purpose, then the enhancement may be different. But for example, some person wants to advertise the something. They wants to use it on the display, or they want to make it the part of the media content. Then see quality of, then it may be the different type of enhancement. So what is the, so how will the things vary? Things will vary. See, for example, your output, what output you want to get. In one case, output x1 or output y1. In another case, it is output y2. And thereafter, y1 and y2, the in-between step, that y1 and y2 actually will decide that how you need to do the enhancement. We will understand this operation also, how mathematically does it take place. See, what is in our sessions? In our sessions, what we will do in the afternoon sessions, basically, we will take up some problem, some mathematical problem. So see, once you are able to understand these mathematical problems, so we will able to see that how the things are actually going on. So we have planned the course in a way that in the morning, most of the times we have the theory part or the fundamental part, and in the afternoon part we can have the problems part, in between problems part, so that we can see the application, we can see that mathematics, that how is it going on and how is it really changing the thing. See, whenever you hear this word, spatial domain means basically your spatial, see, it is basically the pixels only. When you are dealing the operations directly with pixel value. Again, see, whenever we are saying the pixel, it is a pixel intensity only. Then the frequency domain methods are there. What do you mean with the frequency domain methods? That are basically based on the Fourier transform of it. So Fourier transform, are you aware? Fourier transform. Fourier transform, basically what does it do? Fourier transform at a one-dimensional level. What we have already seen it, that it is the x of omega is equal to xt e minus j omega t dt. You are expressing the signal into the form of the exponential basis, right? In the form of the complex exponential basis. That is basically the omega. And it is valid for the non-periodic signal. For the periodic signals, initially the things started with the Fourier series, but for the non-periodic and for the actual real signal, it is a Fourier transform. So when this omega comes in picture, then we see the frequency domain. So why some may have the query that why do we go to this frequency domain? See, because frequency domain contains basically see, one thing we need to be very clear that when we are seeing in the frequency in for the image, it is basically the variation of the pixel value. That how these values are varying. Right? For example, if there is a more variation, there is a more variation between the pixel values, then it has the high frequency. If the pixel value, when we move across the image towards the different with the different pixel values, if there is a less variation, then we say it is a low frequency. So this high frequency concept and low frequency concept is actually becomes the basis for finding out the different pattern. That's why frequency domain becomes very, very important when we use in overall image processing. With combination methods, it is not necessary that you have to only apply one of the method. Many times both the methods are used. It is basically spatial also as well as the frequency also. So just why I show you this slide that what do you mean by this operation? We will continue in the afternoon, the same part. The simplest form would be when the neighborhood is of the size 1 by 1, that's a single pixel. See, enhancement, you are basically taking, it may be applied on a 4 pixel, it may be applied on a 8 pixel, it may be applied on a M pixel, but we start with the simplest operation. That is basically the 1 pixel. So what you do, for example, one is basically the gray level transformation. What means the gray level transformation? Gray level means basically the value which you are seeing of the pixel intensity, you are transforming that value. How you are transforming that value? For example, you are applying it. This is what is this capital T? This is some transformation function. Where is it working? It is working on that input value. On that input value, it is multiplied by n. Initial value of that pixel was basically R, and then after multiplication, it has become TR dot. Since it's a single point, that's why we are saying it is a point process. So please be clear that it is S equal to capital TR. This is basically the new output value. So what has happened in the image enhancement, that your pixel intensity value or the pixel value has been changed by applying some function, some transformation function. So here concluded for this session. Multiplication, see, multiplication, not see, actually, it is not here, see, it is basically S equal to this value has changed. It is no more multiplication. Sorry. It is only this value has changed. Initial that value was R and it has changed to N. Anju, is it clear? No more it's multiplication, it's only transformation. Transformation, that some function capital T is there and you have provided the value, input value, a small r, and it has become. So now we have started basically with the operation on the image. See, what do we do as an engineer or as the image processing? We process the image. Process means basically in simple words, we apply some mathematics. We change that value. Transformation means from one domain to the another, because see what we are seeing, that the one part your initial image, another part is your output image. So that way you can say it basically the trans. That's why see if you are seeing this is basically a function. That it in case of it is more than the 1 pixel value, then what we say, then it is basically the another transformed image or the transformed segment actually. For example, capital T, what may capital T? It is maybe equal to R square. Transformed in what sense? It transformed basically that your value has changed by the function. Again, see, as we already discussed that capital T basically indicates it depends upon a specific application. See, for example, x becomes 2x, x becomes x square. Exactly. These are the one of these examples. Why transformation is required? See, transformation is required because see, for example, if I want to see the two different, if see the image, some blur image, and I am unable to differentiate the different regions in that image. So what should I do? Remember here I can those regions which are at the boundary level, if somehow I can enhance that boundary level, it will be much more easier for the machine to distinguish between the different regions. That's why transformation is required to make the life easier for a machine. Because see, as our processing is very, very sharp, very quick, in case of machine, it is not there. You need to provide every fundamental thing to the machine. That's why transformation, to make the things easier, to make the things simpler. Anju is asking, is G the two-dimensional? Let me complete it. Is G the two-dimensional function that gives the intensity value of the G, but I am unable to see the G? Also, then G depends only on the value. Yes, basically, see, right? See, what we are seeing here, G is basically for example, initially it was, see, how do we represent the each pixel in the our original image? It was fxy. Now it has become gx of y. Exactly. Are you seeing here that this is basically fxy? So this function has been changed for whatever pixels are there. It has been shown here that this initial fxy has become gx. Original function was fxy and it has become gxy after the transformation operation. Session will start at 3, from 3 to 5. So I think we now take up a yes, it is 3 to 5. So it is, so we have actually intentionally kept it. Upload, definitely we will upload the PPT for you. And even we will revise it. For example, if I feel it that somewhere sufficient diagrams are not there, as I saw it in the some slide, we will provide it and so that you can better understand. Okay, thank you. Have a lunch break and then we will meet at 3.